Hey guys, welcome to Civil Engineer SATA. My name is Abhishek Kamdar. So today we are going to solve problem. So let us start. The problem is on based on engineering mechanics. Determine the resultant of concurrent forces at O as shown in figure D. So you're able to see the question is ready. So let's start our solution. Okay, before this is a hexagon actually. This is a regular hexagon. Okay, so I hope you got this. This is a regular hexagon. So resultant force of concurrent forces you have to find. So let's start. So one property before doing that you have to understand is about the hexagon. So in hexagon, all the sides will be equal. Here, all the sides will be equal. Okay, and also the internal angle between the two sides is 120 degrees. Okay, so the internal angle is 120 degrees everywhere. It is 120 here, here as well. Okay, so in that case our complete angle here would be how much? I hope you are getting that point here. So that would be 120 degrees. So, but I want the individual angles. Okay, I want the individual angles here. So one part, one, so two, three, and four parts. So totally four parts. So hence what I'm going to do. So 120 degree divided by 4. Okay, 120 by 4 will give me 30 degrees. So that each and every angle here it is interlinked by 30 degrees. Okay, so I hope you got the things here. So let's start the solution. We have to find the resultant, so we'll do that here. So let me take it down. Yeah, so now the first thing here is you got the angles here, intermediate angles. So how much you got them? You got them as 30 degrees, 30 degrees, 30. The solution. So first we will focus on 900 force. Okay, so let's call this force as F1. Let's call this force F2. This is F3 and F4. Okay, F4. Okay, so let's start for force F1. For force F1, what I'm going to do. So now, so how much is that force? 900 newtons. Angle inclined is 30 degree to the vertical. So what, this is y-axis, this is x-axis. So the component here it would be what it would be, the component in the y direction, the component along the y direction is 900 cos 30 degree, because the angle 30 degree is attached to that side, okay, to the y-axis. So now here the direction of x is on negative side of x, or in diagram don't write any sign. So this is 900 sine 30 degrees. Okay, so let's start writing here. So it is on the negative side, so minus 900 sine 30 degrees into vector I plus upward. The upward force is positive, so 900 cos 30 degree into vector j, okay. So let's see this. So this is the force F1. Now let me calculate this 900. So this is minus 540 into vector I plus 900 into cos 30. So 900 cos 30 is plus 779.42 into vector j. So this is for the first force F1, which we have taken that as 900 kilonewton, 900 newton, sorry. So similarly we have to do for force F2 as well. For force F2, Again same thing, again consider xy plane. So just consider your xy plane here. Now the force is directly along the F2, 150 Newton, directly along the y-axis. You can see the force is directly along the y-axis. So let's consider that. So now we'll see the force is 150 Newton. The force is 150 Newtons. So this is y-axis, this is x-axis. Okay, so let's see. There is no angle attached to this force. So the force F2 is simply, there is no x component. So 0 into vector I plus 150 into vector j. So why it is plus? Because it is in the positive y direction. So finally this is 150 into vector j. Okay, now for force F3. Now let's see for F3. Okay, for F3 again same thing. Consider the xy plane. Yes. Now the force F3 here, it is 500 Newton. See, one very important observation that you have to make is 500 Newton, it's inclined to the vertical with what angle? 30 degrees. Okay, 500 inclined to vertical. So 500 Newton inclined to the vertical 30 degrees. So this is y-axis, x-axis. Now let me resolve this force along the x-axis and y-axis. So you can see along the x-axis the force would be 500 sine 30 degrees. Okay, wherever it is attached to that side, no, that it would become cos, force of cos included angle. So 500 cos 30 degrees. So now the force F3, so I'll just write it from the beginning here, so that would give me more space. It is first x-axis component, so 500 sine 30 degree into vector I plus, it is in the positive y-axis, so plus 500 cos 30 degrees into vector j. Okay, so F3 sine 30 is 1 by 2, so 250 into vector I plus, so 500 into cos 30 is what I'm just operating the calculator now. So it is 433.01 into vector j. Okay, so this is the force F3. Now we'll go for force F4. So F4 force is having an angle of what? It is having an angle of 30 degrees. The force F4 is having an angle of 30 degrees with the horizontal. Okay, with the horizontal it is 30 degrees. So let's start. So let's start the thing. So again, let's take the XY axis. So let's go here, take XY axis. Okay, now let's see the angle 300 Newton, 30 degree to the horizontal. 300 Newton, 30 degrees to the horizontal. So let's select this 300 Newton force. So with horizontal 30 degrees. So the components here it would be what? So this is x-axis, this is y-axis here. Now this is 300 cos 30 degrees. So here 300 sine 30 degrees. So this is origin O. Now the force component F4, the force component F4 would be 300 cos of 30 degrees into vector I plus, it is again the y component here is in the positive direction of y-axis, that is 300 sine 30 degrees. Okay, 300 sine 30. So this is my S here actually, sine 30 degrees into vector j. So the force F4 is, so let me check, 300 into cos 30. That would give me 259.80 into vector I plus 150 into vector J. Okay, so this is the force F4. So lastly for force F5, so this would be very simple, I think, because the force F4 is not having any angle, included angle, only the value of force here is along the x-axis, so that is 200 newtons. So that is directly we can take that as 200 newtons. So this is directly here, so 200 newton, so on x-axis here and y here, so this is the origin. So the force F5, only x-axis is there, that is also in the positive side. So 200 into vector I plus 0 into vector J, just for confirmation. So 200 into vector I. So this is the force F5. Okay. So this is equation number 5. Let me call this 4. So similarly 3, 2 and 1. So this is 2, and lastly the first one would be 1. So now to get the force, resultant force, so to get the resultant force, so let's have the summation of all the forces F1 plus F2 plus F3 plus F4 and plus F5. So only thing you should remember here is all the all the forces, okay, all the forces x components should come in one side and the y component should come. Like what I mean to say here is, so first here what we do, we take the x component is what, minus 450. We add with the I component here is 0. Next I component is F3, force 250. Next I component of force F4 is 259.80. We add the I component separately and J component separately. So that will make, that would give a correct expression. So minus 450 plus 0. So let's start writing here, minus 450 plus 0 plus I have to see F3, 250 plus 250 plus 259.80, 259.80, and lastly plus 200 into vector I plus, now similarly for vector J, or J 779.42, 779.42 plus 779.42. So J, in case of J, we have 150 plus 150 plus 150 plus 433.01 plus 433.01 plus last one plus 150 plus 150. Okay, plus 150 plus lastly to, we don't have anything, but still for indication purpose write I 0 into vector J. So now we have to add this equation. So the final answer of the force F would be 259.8 into vector I plus 1554.01 into vector J. So now to get, this is the vector expression, this is the final vector expression. So to get the force, we have to get what? We have to take the summation of 259.8 the whole square plus 1554.01 the whole square. So let me do it here, 259.8 the whole square plus 1554.01 the whole square. So that would give me, that would give a value of around 1575 point, let's say 6. Okay, 1175.6 newtons. Okay, now after seeing the final vector expression here, so this is the final vector expression for given force system, so after seeing this, if I want to write a resultant actually here, if I want to write a resultant, then what I would do here is the x component here is in positive side. So let me take a positive side arrow mark here. Let's say this is 259.8, and the j component also positive. So the j component is also positive. So let's take again a positive direction, 1554.01. Now finally the resultant would be somewhere here. Okay, this finally the resultant would be somewhere here, which is having, let's say it's having an angle alpha with the horizontal. So the value of alpha is tan inverse. Okay, tan inverse of what values? So the tan inverse of fy by fx, fy by fx. So that would be tan inverse of fy is what? 1554.01. This is the value of fy, and this is fx. Divided by fx is 259.8, the value. Okay, so let's start this calculation. Okay, so let's see this value. So this value is around 80.51 degrees. So the alpha angle is attached with 80.51 degrees. Okay, I hope you understood solving. We have got both magnitude. We got both magnitude and resultant, magnitude and direction. Okay, sorry, and magnitude and direction of resultant, magnitude and direction of resultant. So I hope you got solving. So this is simple. The method is same, but the figure, the shape and size of the shape and the dimensions may get changed, but the concept here is very same, almost same for all the problems. So thank you for watching my video. If you like, please do subscribe the channel and share to your friends. So let's meet in the next video with a different concept. Thank you.